No, I drew all that on the background. Alright, so let's see what we do if we have trans and cis's together. Alright, so let's draw some really odd looking compound here. We're going to have this. That. And that's actually really ugly. Okay. That. And that. Okay. Cool. So, let's number our chain. We have a 1, no, 2, 3, 4, 5, 6, 7, 8. Okay, we see that we want to number this the lowest way possible, so we're going to start numbering from this side, where the 1 is, and we're going to identify where our chains are. So we have a 1. Uh-oh, I didn't number that right. Let's go back. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so identify what groups your branches or your alkenes start. So it starts at the 1, starts at the 3, starts at the 7. Okay, so now let's identify whether they're trans or cis or neither. So again, this is going to get ugly. Okay, so draw a line right through this one and a dashed line. We see that the heavier groups are on this side, also over here on this side. To connect these, it's going to be really messy. We have to cross this line. So we can conclude that this one here at 7 is a trans. Okay, so what about this one here? Let's draw a line right through it. Okay, cool. So now let's draw a dashed line. Okay, it's getting pretty messy. It's not a big deal. And we see that to get from the heavier group to the heavier group, which is over here, and it has to go down over here. So we said this is also a trans. What about this one? This side's heavier, but over here, there's just 2 hydrogens coming off. They're indistinguishable from one another. So this is neither cis nor trans. So numbering this, we start with nonene. But this isn't just any nonene. There's 3 of them. There's nonatriene. Okay, so now let's number these. So we have a let's start with trans. So we have trans, and then we have a 2 and a 3, and then we have nothing, just an alkene at 1. So we put the 1. Okay, but now that 1 here looks like it's a trans. So if it's by itself and it's not a cis or a trans, you number it before you start numbering the cis and trans. This is like saying there's an alkene at 1, and then there's a trans alkene at 2 and 3. Alright, so let's draw another one. Okay, so we have a 1, 2, 3, 4, 5, 6, 7, 8 here. Identify which ones your alkenes start on. So they start on 1, they start on 3, and they start on 6. So we see that this one here, because from go to one heaviest group to the other, you have to cross the middle. So this is a trans. If you look at the next one, you see that to get to one heaviest group to the other, you don't have to cross the double membrane. So not double membrane. Sorry, I'm starting for cell. Okay. So you don't have to cross the double bond. So this is a cis. This one here, again, there's two hydrogens coming off here, indistinguishable from one another. So you have to call this is neither a cis or a trans. So this is basically nothing. Okay, so let's name this. We have a oct group. It's an ene, but it's an octatriene because there's 3 of them. Okay, so again, start numbering the neither cis nor trans alkenes first. So we start with 1. Then you go up and you have a trans 6, and you have a cis 3 octatriene. Okay, that's actually, let's do a ring structure first before we call it quits. So alright, so what is this one? Okay, so start numbering. You can number from anywhere you want. So this could be a 1, 2, 3 or a 1, 2, 3 because alkenes take precedence. So you name this as 1, name this as a 2, this has to be a 3, 4, 5, 6. Alright, so this is 6, so it's a cyclohexene. The alkene group starts at the 1, and as you can see, it's a cis. However, for alkenes, trans, I don't really think trans is possible underneath a ring that has like 10 or 12 carbons, which isn't very common. So you don't even need the cis in a ring. You just put 1 cyclohexene, except now we have a methyl group. So we have name this 3-methyl 1 cyclohexene. Okay, I think that's pretty good for alkenes. They are quite difficult. Oh, I'm going to have to split this into 2 parts. That sucks. Alright, anyways, alkynes are next. They're really, really easy.